So good morning once again, class. We have today we're going to continue our discussion on multiple linear regression. So far, what we have done was to find the best model using a set of predictors. We used what we call the stepwise regression, in particular the backward stepwise regression, where we first have this complete model, and then one at a time we remove those predictors that are not significant, particularly basing it on the p-value. Okay, so let me create, this one. So my wage is already here. So just a quick review of this one, where we said that we would want our independent variables, our predictors, to be highly correlated with our dependent variable. In this case, we can see that education is moderately correlated at 0.4, but relatively it's the highest among the different predictors that we want to use. Okay, I removed here, which we did before. I removed the factors. Okay. Okay, we already did this class. That's why I'm not discussing this with you anymore. I just wanted to show you a review of what we have done, and just be reminded that we want the predictors to be highly correlated with your response variable, with your dependent variable, but not the predictors highly correlated with themselves. Okay, we do not want that. Okay, so let's create this object mod. Okay, let me pause for a while. Were you able to open already a new RMD file? And did you already load the wage dataset? May I have your response, please, so that I know if I can continue already. Okay, good. Thank you. Okay, thank you. Let's give your classmates a few more seconds to respond. Okay, thank you so much, class. All right, now we look at a method in regression, which we call stepwise regression in greater detail. When we do stepwise regression, what we do is either we we start with a base model, which is just using the mean, the average, without using the predictors, and then one at a time insert or put into the model the predictors. That's what we call the forward stepwise regression. The opposite of that is the backward stepwise regression, where we put all the predictors and then one by one remove the predictors. Now, it's a good model, it's a good methodology. However, at the onset, let me remind you that there are disadvantages of this process, okay, which we'll discuss later on, and not today, of course, when we do quantile regression. Okay, we're going to learn what quantile regression is, which is an alternative to OLS. Okay, so let me see. I don't have the mod first yet. Okay, so let me create this object, which is just the LM model. Okay, as you can see, this is a list of, this is an LM object, regress on everything. Okay, you know what this means, right? Data is equal to wage. Okay, good. Now, I invited you to open the OLSRR documentation. Let's take a look at that, because this is very important for us. This is the package that we're going to use that will really make stepwise regression very, very easy for us. Now, of course, we won't be able to discuss everything here, but because you have this reference, it's really very easy. It makes the process of stepwise regression easy to follow because you have this reference. So here in the guides, you have the different functionalities. For example, this one, residual diagnostics. If I click this, then you will have here what are the functionalities that you can use from OLSRR in order to check the residuals Okay, you can use the OLS plot recede QQ. This is the QQ plot. Or you can also use the checking for normality, checking for this one, the correlation, the variance inflation factor. Then this one, you can plot the what's this? The plot of the residuals versus the fitted values. And as we already discussed before, we want that the residuals, when plotted with the fitted values, it should display a constant variance. In this illustration, there seems to be a fanning. So this is not a homoscedastic residual distribution. And we also have the residual histogram. So these are the things that we can use. You can use the functionalities. We also have the measures of influence. This is very important for us because we'd like to know which of the data points influence the parameters, influence the results of the regression model. And one metric to use that is the Cook's distance. Okay, the Cook's distance is a measurement of the influence. So what's done here is that it removes each of the observation and then runs the regression line, and it will compute how this particular data point affects the regression output. We also have the F betas, the F fits, okay, student standardized residuals, standardized residual chart, quite a lot here. Okay, quite a lot of metrics by which we can identify outliers, not only outliers, but in particular influence points, because influence points are more important than outliers. As I said before, outliers, an outlier, an influence point will always be an outlier, but an outlier may not necessarily be an influence point. Okay, what is relevant, especially as to the effect on the regression model, are influence points and not necessarily outliers. Okay, so there are different measures of influence. Now, of course, we won't be able to look into this, everything of that. We will consume a lot of time if we look at that. However, I'm sure you will be at your disposal. You can on your own also look at the different metrics, and I'm sure you'll understand. Understand this. Then there's this reference for heteroscedasticity, which we said is very important to look into, because if the residuals, if they're distributed, the variance is not constant, then the model is of course still linear, it's still unbiased, but it will not be the best. So we're not able to generate now the best linear unbiased estimating. Okay, and there are ways to correct that. There are ways to address that, which we'll be looking into. Maybe not today, maybe next meeting, because we are covering a lot of things here. So for example, here it tells us that there are several tests for homogeneity of variance. One of that is the Bartlett test. Another more popular one is the Bruce-Pagan test. Okay, so this is just the test, OLS test, Bruce-Pagan test. So it's quite easy, class. It's quite easy to statistically test for heteroscedasticity. Okay, we'll go into this later. Okay. All right. So other tests also. Now let's go to the guides. Collinearity diagnostics is very, very easy to do, because we would like to test if our predictors, if our independent variables are not correlated, and we use a metric called variance inflation factors. Variance inflation factor. Okay, when this metric tells us that the use of these predictors will inflate the variance, will increase the variance, which makes the model heteroscedastic. So this has an impact on the heteroscedasticity of the model itself. So there are ways to address this. So the VIF is related to your tolerance. Your tolerance is simply 1 minus your R K squared, and that's related to your VIF. Your VIF is simply your 1 over your tolerance. Okay? All right. So and then here you have your variable selection. Okay. So variable selection allows us, this is what we're going to discuss now, allows us to determine which is the model of interest, okay, that we want. We'll go back to this one in a while. Okay, so here we have your stepwise forward regression. This is the function that we use, OLS step forward. And you can use the p-value, P, or the AIC. AIC method, where's that? Okay, okay, later. And then we have the stepwise backward regression. And we can also use the both the stepwise regression, which where you can use a combination of forward and backward. Okay, so this is quite an extensive, comprehensive tool that we can use in diagnostics. So let's start first. So I hope you have created this mod. Okay. Let me just delete this diagram. Okay. So let's put here some notes. OLSRR. Okay, and what are the different methods that we can use? So we can use the stepwise regression using P, and 2 we have stepwise regression using AIC. So what we mean by using P or using AIC is that whatever variable will be chosen to be part of the model will have to be chosen via the P value or the AIC value. Then you have the stepwise. I'll just copy this. Control C. You have the forward stepwise using the P value, and you have Control C, Control V. That's number 4. Forward stepwise regression using AIC, and that's Control C, Control V. And then number 5, we have the backward stepwise regression using P, and you have the backward Control V, backward stepwise regression using AIC. Okay, so let's take a look at this and let's try to compare. Now, one of the main, let's say, disadvantage of using stepwise regression, whether forward or backward, is that this model sometimes will generate different results. So forward regression, for stepwise forward, stepwise backward, it will generate different final regression models. Okay, so that's one disadvantage of that. So that's why maybe, not maybe, but we'll take a look at another method, which is called the quantile regression, which proves to be a more powerful method compared to OLS, ordinary least squares. Okay, so let's first, let's now do this. Control C, Control V. Okay, so if we take a look at, okay, the function is OLS step. Okay, I think you should first, please load first OLS, otherwise you'll not be able to make use of the functions of OLS. Maybe you can just type their library, or let me just put here library, or just the pacman. Okay, the payload. Then OLSRR. So let me load this. Okay, then if you type OLS underscore step. Okay, so you have here so many functions. OLS step all possible, OLS step all possible betas, backward. You can see here backward, then backward AIC, backward P. Let's go down. Then you have best, then both. Okay, forward. Then you can use step AIC. It's the same. So we're going to use the ordinary stepwise, which means that it combines both forward and backward. Take note, the difference between a forward stepwise regression is that for a forward stepwise regression, it starts with nothing, no predictors, and then it injects or it introduces the predictors into the model depending on the parameter, depending on the benchmark or the method that we're using, either the p-value or the AIC value. So let's first start with this one. Okay, OLS stepwise both. So we're going to use the model that we created here, the mod. Okay, mod. Okay, and then okay, we already identified what mod is. So it's better to do that instead of putting the whole model here. This is more convenient to do. And then let's put here details, okay? Because we want to see what happens. And then details is equal to true. Let me just create another one here. Let me separate the Control X. So let me separate the loading of the package. All right. So what did I just do now? Let's create an object for this. Okay, what can we do? Let's say both underscore P. Okay, so this is stepwise using both and then using P. So let's name this object OLS step both P. We're going to perform that on the model, and then details is equal to true. Okay, let's run this. Okay, and then it will give us all the steps. And let's try to see what's happening with our model here. Okay, before I discuss this, kindly chat please if you were able to generate this. Okay, it's quite a long output here. Okay, of course, when for example, in your group exams, you don't have to write this, or if you want, you can just put this in the appendix. Okay, because we're just doing this for discussion purposes, so that we know what's happening. All right. Okay, let's try to see the let's see the output here. So selection, stepwise selection method. So these are your predictors, and then notice that it's a stepwise selection. So the stepwise regression is at the start, it's similar to your forward stepwise regression because it starts from scratch. Okay, it starts from scratch, and then take note. Step one, it will add. The first one it will add is education. Okay, and it's based on the p-values. Okay, and then these are the measures R squared. If you remember, class, for this simple linear regression where education is the lone predictor, the adjusted R squared was around 16.3. Okay, if you recall, 16.3%. And there are other measures here. This is your root mean square error. Okay, this is the your residuals squared, square of your residuals, and then you get the average, and then you get the square root. So that's a Ramsey. Okay, this is your standard error. Okay, so that's your residuals squared, and then you get the average, okay, and then you get the square root. And then you have this coefficient of variation, the mean square error, and the mean absolute error. Okay, so some metrics here. Okay, if you see class, if you get the mean square error, Control C, Control V, and if you get the square root of that, okay, this one, right? This is the Ramsey now. This is the mean squared error, which is your residuals, okay, which is obtained by your y minus y, your yi, your actual minus your predicted value, and then you square that. Okay, we square it because if we add it, it will be equal to 0. So we can't get any information out of that. So if we square the sums of your residuals, that will be your MSE, mean squared errors. And then you get the square root of that to get the Ramsey. Okay. All right. This one is your mean absolute error. Okay. How do you get this? You just get the difference. You don't square this. Get the difference, and then you just get the absolute value. Okay. So it's either y sub I minus y hat or y hat minus y sub I. Get the difference and then square that. Get the absolute value. Okay, so that it will all be positive, and get the average, right? Okay, so you notice it's lower than MSE. Both are means, right? It's lower than MSE because this is not squared. This, on the other hand, is the square of your error terms. Okay, so let's continue with this. Now we perform ANOVA here. So what's the analysis of variance here? You're comparing the difference between the model, your restricted, which is just the average. Okay, remember, we're starting from scratch. So we introduced education. So the degree of freedom here for the regression is one predictor, which is education. So versus no predictor, right? And you have a p-value equal to 0.00. And if you recall, class, the null hypothesis here is that the restricted model is better. What is the restricted model? No predictor, just the average, just the intercept. Okay, and we reject that hypothesis. We reject the hypothesis that the restricted model, which is having no predictor, just the intercept, just the average, is better. Okay, this is what we have been discussing before, right? So this model, the one with the degree of freedom 1, the predictor, which is education, is better than the one just getting the average of your hourly wage. Okay, so there are some more statistics here. You have here your beta. This is your coefficient. Okay, and then this is your significant p-value. If you recall, dun sa ano natin in our simple linear regression, the intercept was not significant. I hope you recall this, but the education was significant. Okay, then since this is stepwise regression, okay, step 2 plus tenure. Now in stepwise, you can either add or subtract. Okay, that's the difference between stepwise and forward stepwise and backward stepwise. For stepwise, it's both directions. You can add and subtract. For forward stepwise regression, you can only add. Okay, once you add a particular variable into the model, you can it is no longer removed. In the same manner, for backward stepwise regression, once a variable is deleted or removed from the model, you cannot anymore put that back. Okay, but for stepwise regression, if a variable is removed, it can still be put back. Okay, here the second model is tenure. The second variable to be added is tenure. And then what's done here is that, again, mag-ANOVA dito, no? Okay, this time the degree of freedom is 2, which means 2 predictors. And this is compared with the previous one, the restricted model where you only have education as your predictor. Here you have now education and tenure, okay? And the p-value is 0, okay? Which means that we reject the null hypothesis that the restricted model, which just includes education, is better. There's statistical reason to believe that it's the one with tenure, adding tenure to the model is better than not adding tenure. All right, and then we have the summary of the values. Yeah. Okay, you have the beta for intercept, the beta for education, and the beta for tenure. Now we have here your standard beta. Okay, we will discuss this because this, in this case, you actually notice that for a standardized beta, there's no intercept. Okay, because for a standardized beta, and you notice it's quite different from the beta. Okay, the standardized beta is generated by standardizing your variables. Okay, when you say standardize, you subtract the average of that variable, and then you divide it by the standard deviation of that variable. Okay. All right. So, but we'll discuss this in the future. All right. Then next is, okay, what happened next? Okay, number 3, plus. So we add gender to the model. Okay, and once again, the ANOVA tells us that this model, the one with the 3 predictors, we reject the model, the hypothesis that the model with the 2 predictors, the restricted model, is better than the unrestricted because of the p-value here. Okay, so this is consistent with what we have been discussing before, right? And once again, this is the summary of the parameter estimates. Okay, and here you can see that indeed these values, these parameters are significant. You notice that in this 95% confidence interval, this is the lower, this is the upper. Okay, and the value of your beta lies between this. You notice that in this range between the upper and the lower, it will not reach 0. It will not touch 0. 0 is not in the middle of this. So there's no possibility that the betas here could be 0. Okay, since the lower is 1.267, for example, for male, and the upper is 2.3, then no way for 0 to be in between this. Okay, so this is just a review of what we have been discussing in your elementary statistics class. Okay, and then we have now, okay, this is just a repeat of the ANOVA. Okay, and then is there any other variable to be added? Nauulit, ano? I noticed that it's repeated. All right, then step 4 is you add civil status. Okay, and then you can see now, once again, we have this analysis of variance. So we reject the hypothesis that the previous model, the one with three predictors, is better than this one. This model, the one that adds civil status, this one plus civil status, is better than the other model. Okay, and then we have, once again, the values here, and then the significant, the p-values are all significant. Okay, and let's see, the last one is there. No more variables to be added. Okay, and you have the final model output. Here, and this is similar to the one that we did before. Okay, so in this case, the forward, no, this is the both methods. Both methods is the same as our backward stepwise regression. because we were able to generate the same parameters, and they're all statistically significant. Okay. All right. Let me pause for a while and please comment if so far okay yung ano natin yung this is just the first of 6. We'll go through the others quicker this time kasi I think you already know what the process. Okay, class, kindly chat please if if it's clear so far, or in case you have questions, you may ask your questions now, please. Okay, good. Thank you. All right. So let me just close this. All right. And the next one is, okay, it's the same stepwise regression. Let me just copy this, everything here. Control C, Control V. Okay, let me call it number 2, and then this is stepwise regression using AIC. And then both, let's make it both AIC. And then the difference is that OLS step both we changed with AIC. So it's very easy to manipulate it, to just change the names, okay, and then it will give us the output that we want. Okay, thank you for your comments. Okay, now what's the difference between this one and the first one? For the first one, a variable will enter if its p-value is okay. Okay, if it, for as long as its p-value is less than 0.05, then we're okay. For this one, what's the basis? If the AIC goes down, then we still include that variable. Okay, so let's run this and let's include the details is equal to true so that we see what the process is. So the OLSRR is very useful class, especially if you have several variables. And of course, we don't want to manually do the stepwise regression, the backward stepwise regression. The backward stepwise regression is easier to do compared to the forward, because in the backward, you include everything first, and then you check which has the lowest absolute value of t, and then you remove that. And then once again, you do a model, and then you compare if the restricted model is indeed better than the unrestricted model. So we now have this output. Okay. So once again, we have the candidate. So this is both. So it will start from scratch. Okay, so notice, okay, it will look at what will happen if we enter these variables one by one. So notice the degree of freedom is 1, which means it will enter it one at a time. And if we enter education, the AIC is 2777. If you enter race, the AIC is 2871. Therefore, the best variable to enter is education. Why? Because it will have the lowest AIC. Remember, this method is AIC. Okay, so enter education now. So education plus, and notice what's being measured now is not the p-value, but rather the AIC. Okay, so now our model is hourly wage regression education. Okay, next step, what happens? If we enter race, the AIC will be 2779. But if we enter tenure, the AIC will be 2685. So among this, which is the better variable to enter the model? It's tenure, because it will generate the lowest AIC compared to the other variables. So what happens now? We added tenure, and then you notice that AIC has become 2685. Was there an improvement in AIC? Yes. Originally 2777, if we just model using education. But with tenure, the 2777 became 2685. So there was a lowering of AIC. And once again, so this is now your model. Okay. Now, as I said, in the both method, you can, since you already entered education, you can still remove this. Okay, you can still remove this. Okay, but it tells us that if we remove education, what will happen? Okay, take note of this, remove existing variables. If I remove education and just put tenure, okay, our AIC will be 2804. Our current AIC with this two is 2685. So we cannot remove this. Okay. And if I remove tenure, then we'll go back, we're going back to the previous model, right? Na 2777. Okay, so I hope you're reading, you're understanding what's happening here. So you notice our OLSRR will ask, can we remove variables? How about entering variables? It will take a look at it from both perspectives, from both ends, removing and adding. That's why I said that in this method, both variables that have been entered can also be removed. Okay, and variables that have been removed already can also be returned. Okay, so how about this? Entering variables, what happens? Will adding any of this, for example, gender, will it improve the AIC? Yes. This is 2643. Notice it's arranged according to their degree of reducing AIC. If we include race, then our AIC will become 2687. Our AIC is already 2685. If we include race, then AIC will go up, right? So what's the point? Okay, that's why we're entering gender here, gender. And the AIC became 2643. Is it an improvement? Yes, because from 2685, it became 26.43 there. And now we have three predictors: education, tenure, and gender. So once again, we repeat the process. Are we going to remove any of the variables here? Okay, our current AIC is 2643. Removing education will jack up your AIC to 2758. Removing gender will once again go back to the previous model, 2685. So it makes no sense to remove any of these existing variables. Okay. How about entering new variable? By entering civil status, you get an AIC of 2639. Okay. So among the options here, this is the best. Because if we enter experience, the AIC will be 2640. Okay, take note. It's only entering one variable at a time. Okay. So enter civil status plus civil status. So we now have this model. Step 4, AIC is 2639. Okay. And the model is hourly wage. We're regressing education, tenure, gender, and civil status. Okay. Then we now have this model. We now have this choice. Are we going to remove an existing variable? If we remove civil status, which is just what we entered, then we go back to the previous one. If I remove education, then again, your AIC will jack up to 2751. So we're not going to remove anything because AIC will increase if we remove anything here. How about adding? Adding. Okay, if we add experience, then our AIC will become 2638, which is lower than 2639. Okay, so now we add experience. Okay, so plus experience, our model is now education plus tenure plus gender plus civil status plus experience. All right, then our AIC now is 2638. Anything to remove here? Nothing, because if we remove experience, then it will become 2639 again. Okay, so last, enter new variables. Are we going to add anything? If we add number of dependents, what happens? Our AIC is 2638.6. If we add number of dependents here, it becomes 2638.8. All right, so this will increase AIC. Therefore, the process stops here. We're not going to enter this number of dependents because it will increase your AIC. 2638 compared to 2638.6 compared to 2638.8. Okay, that's why it says here, no more variables to be added or removed. All right. Okay, let's take a look at our final model. Okay, and then we're doing ANOVA. So we're comparing this model, the one with experience, with the one without experience. Okay, and what's the verdict? What's the verdict? We reject the null hypothesis that the previous one is better. So in this case, the AIC, the one with 5 variables, is better. But take a look at this. Okay, take a look at our p-values. Okay, education tenure. All right, your experience is not significant. It's significant at only it's significant at not even 10%, no? Okay, so this is the problem with this one. So we included experience even if that variable is not significant. In fact, if you take a look at the confidence interval, okay, this one, it's between 0.005 and 0.042, which means that this will touch 0. 0 is between these values. So there's a possibility that experience is 0. Okay, that's a possibility. So I should say that this is one of the weaknesses of the AIC method. Okay, because although we included experience, the AIC went down. However, it will violate some fundamental assumptions as far as including a specific variable is concerned. Okay, because there's a possibility that your experience is equal to 0. The null hypothesis here, if you recall, is beta 5 is equal to 0. So what's the possibility that that will be 0? There is that possibility that can be seen in your p-value and also in your confidence interval. All right, pause for a while, class. Any questions about AIC? Both method, forward and backward AIC. Hoping for your response, class. Okay, good. Thank you. Thank you for your responses. So I'm happy, class. I'm confident that we were able to identify a method by which we will not need to manually do stepwise. Okay, so let's take a look at this. This one, forward stepwise, Control C. And then there are two ways again, forward stepwise, using P and using, let me just copy this. Control C, Control V. So this is method 3. Let's call it forward stepwise using P. So we will now use this forward P. So let's call it forward P. OLS step, and then we replace this by forward. Okay, so that's the function. And then let's replace this by P. All right. Now, I want you to notice something here. Okay, let's see. Let's run this. So forward P is OLS step forward P. This is the function. And we're doing this on the model object, then details is equal to true. So let's see what happens here. It's running, it's processing. And let's go to the end value here. Okay, what do you notice? Our final value is education, tenure, gender, male, civil status, experience, number of dependents. Any comment about this, class? What do you think happened? Any comments? Yeah, thank you, Jonas. Yeah. Previously, number dependence. Did you just mention that, Jonas? Previously, number dependence wasn't included during the stepwise. Yes. Diba? But let's compare it with the P method because the previous one was AIC. This one is forward P. Let's compare forward P with both P. What's the difference? Forward P with both P.
Sir, pati rin po sa both P. Wala yung number of dependents as a
Yun lang?
variable.
Sa both P, number of dependents lang?
And experience.
Oh, wala rin experience, di ba? Di ba? Tama, class? Jonas, thank you. You're correct. If we compare both AIC, sa both AIC, walang number of dependents. Sa both P, walang number of dependents at saka experience. Dito sa forward P, bakit kasama si number of dependents at saka si experience? What do you think, class? Yeah, Evan, thank you. More variables, yeah. Why? Bakit kaya more variables? Okay, so sige, discussan natin to in the interest of time. Let's first take a look, class, at OLS step forward. Let's check, no? Forward and then P. Yan. Let's run this OLS step forward. Magano tayo help function. Okay, take a look at this. So ito, no? Build a regression model from a set of candidate predictor variables by entering predictors based on p-values in a stepwise manner until there is no variable left to enter anymore. Take a look at tingnan nyo, is there something there in the default? Is there something there in the default which resulted into that result, which gave that result, class? Tingnan nyo yung class, yung usage. Take a look at the default S3 method. That's why it's important to always check what are the parameters needed in this function. Otherwise, you'll be surprised. Uy, bakit ganun? Diba? Bakit kasama si number of dependents? Bakit kasama si experience? Why? And in fact, if you take a look at the p-values, class, p-value ni experience 0.07. Okay, p-value ni civil status 0.114. P-value ni number of dependents 0.184. Okay, let me see. There's a comment here. P-enter was specified. Yes. What about, Jonas? What about the P-enter? Specified as what? As?
I think it mentions dun sa whatever is a specified value, i-include niya ata yung
Yeah, but the default is what? What's the default?
0.0. Shouldn't it be 0.0?
What's the default? What did this function use as the basis for the p-value? Ito, class, p-enter is equal to
0.3.
0.3, di ba? For as long as the p-value is 0.3, okay siya, no? Which is surprising kasi bakit 0.3 yung ginagamit na? No wonder, itong mga to, civil status, experience, number of dependents, pinasok siya, no? Pinasok siya even if they are not significant, no? Right? Tama ba, class? Okay, that's why we have to adjust this. So when you're using itong forward na P, kanina sa both hindi natin kailangan. Kaso dito sa forward P, may default siyang ginagawa. So dapat we have to adjust this. P enter is equal to 0.05. Okay, so we will impose that any variable to be entered into the model should have hanggang ang p-value na dapat 0.05. So let's run this now. Okay, let's see class. Let's compare. Let's go down to the final output. There you go. All right, tingnan nyo. 1, 2, 3, 4. There. And the significant values are now less than, the p-values are less than 0.05. Okay, so that, just take note of that, class. Yung default ni forward na p is 0.3. I don't know where they got that, why they made that as a default. Okay, so let me pause for a while and ask you if there are any questions. Okay, let me revise my question. Is it clear, class? Clear ba tayo so far? Yung forward P natin. We have done both P and both AIC. So there's a difference between, let's check now. What happens in a forward P? Okay. Forward, it means that you start from scratch. These are the candidate terms. And then first to be chosen is education. Okay. Education, it's entered into the picture. Okay. All right. And then what do you notice? For selection number 2, it entered tenure. Notice that there's no more option to remove variables. Okay. That only happens in the both method. So in both method, in called stepwise regression. So walang forward, walang backward. The model will still choose between removing variables that have been added or adding more variables. So here, no option to remove. So if it's a forward stepwise regression, what we do is just choose from among the different options. So here we added gender plus gender. Okay, why was this chosen? And again, the ANOVA here. So this means that the unrestricted model, we reject the restricted model because of the p-value here. So this, we fail to reject that the model with 2 variables is better. So we have 3 variables here. And then you see, look at this, they're all significant. Okay, so the basis here is that you can put any variable for as long as the p-value is less than 0.05. And lastly, you add here civil status number 4, model summary. And then again, so the unrestricted model, we reject the hypothesis that the restricted model is better. Okay, and then let's take a look at the parameter estimates. You have here your civil status significant at 0.05. So no more variables to be added. Variables entered, education plus tenure, chronologically plus gender plus civil status. You have the final model output here. It summarizes and it repeats. It repeats the regression estimates. The betas, the t-values, the significant, the p-values, and then the confidence interval. You notice that, okay, there will be no potential or possibility that 0 will be a value between the upper and lower confidence interval. All right, so any questions? Clear to class? Clear yung forward P. No? Are we okay with the forward P? So it's quite easy. Okay, once you understand the parameter that's being used, the basis of a variable becoming entering or removing. All right, then let's go again to forward still forward, but this time using AIC. And then forward AIC. And you'll notice that we will once again have a difference between this. Okay, forward AIC. Now, this one, P entering, we will remove this because this is not the basis. Okay, the basis is AIC. So we don't need to put that there. We might have a problem with putting that here, P enter. Okay, and besides, it's a AIC method. Okay, let's run this. And then again, the basis here is that if the AIC goes down, then that variable enters the model. Okay, so let's take a look, for example, at this. Step 1, education only. Just like the both a while ago, but this time there are no provisions for possible removal of variables because this is all forward. Education plus tenure, AIC went down. Education, tenure, gender, AIC went down again, 2643 vis-a-vis 2685. Civil status, again, it went down 2639. All right, and then these are the other options. So will adding experience improve AIC? Yes. 2639 can become 2638. So add that. So this now becomes the final model because if we add number of dependents, our current AIC will go up. Okay. So no more variables to be added. No more variables added. And the final model is we have 5, just like both AIC. Okay. Because with those five, your AIC went down. However, plus, again, the caveat here is experience is not statistically significant. So if we were purely basing it on AIC without any regard for significance, then this is the model. Okay, but as you know, we will have to also look at the whether that any particular variable is statistically significant. Okay, then I hope that's clear. Then let's move on to number 5. So this is number 5 is we have backward this time. Backward using P. And then let me make this backward using P. Okay, so this one, yeah, I make this backward again. Backward using P, all right. And then for this one, since this is backward, I will have to specify that, okay, if I don't specify this, then we will have again an answer just like a while ago when the P value is greater than 0.05. So we will have to put here P rem. Okay, this is P remain. Okay, this is for forward P enter. Okay, so for this one P remain. Okay, so that's a difference. Of course, for forward stepwise regression, okay, what will enter is that the P value should be 0.05. For stepwise regression, since we load everything, okay, we load everything. We put all the variables inside the model first, and then we remove it one by one. So the P that we're going to impose is that P remaining 0.05. Okay, I leave you to check, class. What if you don't put this one? What will happen? And I guess you know what the answer will be. It will include variables that have P values that are greater than 0.05 because of the default. Okay, so okay, excuse me for one. All right, so let me just take a look at the final model. Okay, this is our final model: education, tenure, gender, and civil status. The same as both p-value, the same as what we did manually. Okay, this model, the stepwise p, is what we did in class. It's manual. Okay, if you take a look at the steps here. Okay, so since this is backward, so we first have all of the variables inside our model, and then we are eliminating. So what do we eliminate? The race. Okay, why was the race eliminated? Because it has the highest p-value or the lowest absolute value of t. All right? So we removed race. And if you recall, the next one that we removed is number of dependents. Okay, so this is exactly what we did. Okay, so when we remove number of dependents because what was the reason? Because it has the lowest t value, absolute value in t. And the next one, we remove number of dependents here, yes, because it has the lowest t value. And the next is, what do we remove? Do we remove any other variable? Yes, we remove the experience because it has the lowest absolute p value. Okay, and we remove experience. Okay, and then there's this ANOVA. Okay, again checking if the restricted model is better than the unrestricted. And then here, okay, finally you have this model after removing experience. You have these predictors, and they're all statistically significant. Okay, at 0.05, they will remain. P-rem, P remaining. All right, no more variables satisfy the condition of p-value is equal to 0.05. Then a summary of the variables that were removed, and then a summary of the final model output with a measure of R squared. They call it the adjusted R squared is 36 point, less than 36.20, right? Okay, and then you have the Ramsey, etc. And then you have the analysis of variance. Okay, so we're comparing here is the model that we have now, the one with just 4 parameters. That's the restricted model. Is it better than the unrestricted model, class? Degree of freedom 4. Okay, so we reject the null hypothesis that okay, ano yung 4 natin? That the restricted, wait, dali. This is 4 degrees of freedom, 4 parameters, 1, 2, 3, 4. And then, where are we comparing this with? Where are we? This is okay. This is 0. ANOVA is 4. Degree of freedom is 4. So what is the unrestricted model here? The unrestricted model is 3. Should be 3. So is having 3 parameters better than the problem with this one is we don't have here the model that where there are 3 parameters. Kasi ito 4 na eh, no? So, and we reject the null hypothesis. What's the null hypothesis? Yung restricted model natin. So the question is, what's the restricted model? It should have lesser predictors. But we don't have that. We're coming from this scenario where ilan yung predictors natin? 5 predictors. So I think I will have to check. No? And please help me check why we are getting this. This is backward. No? So we are comparing model 4 with 4 predictors with 5 predictors. The null hypothesis is okay. Unless, all right, let me guys check on this. Kasi this can be quite confusing because all along what we have done is for our analysis of variance, the the standard null hypothesis for that is that the restricted model is better. So we were coming from that model where we have 5 predictors, and we were removing it. So our 4 okay. Okay, so I'm sorry, class. I have to evaluate this, no? Kasi we should be comparing this with the one with. Do you get what I mean, class? Degree of freedom 4. So ito yun, di ba? 4 predictors. So if we're going to do the analysis of variance, okay, I think I know. The analysis of variance here, okay, is not the same as the analysis of variance where we compared models. The analysis of variance here is that the beta null is equal to beta 1 is equal to beta 2 is equal to beta 3 is equal to beta 4. And then we reject that null hypothesis that all the parameters are equal to 0. Okay, so let me check, class, what is the ANOVA for the for this OLSRR? Okay, because we actually have 2 ANOVAs, actually more than 2. We have the ANOVA where we're comparing the 2 models, 2 regression models. In that case, the null hypothesis is that the restricted model is better. Okay. And then there's this other ANOVA, which is the overall goodness of fit test, where the parameters, all the parameters, including the intercept, is equal to 0. That's the null hypothesis. So in this case, I think the null hypothesis here is that all the parameters, this one, are all equal to 0. And we reject that. Okay, so this has nothing to do with comparing this with the unrestricted model. Okay, is that clear, class? Because you might get confused. Why is it that we're comparing model 4 with we're comparing degree of freedom here is 4. So which means that there are 4 predictors. Hindi siya yung 5. It's not this one. It's not this one which has 5 predictors. Okay, sige. All right. So I'll validate that, guys, and then get back to you on that next meeting. But that's good because we're really looking at this. Okay, then I will not anymore go into the 6th one. I will leave that to you guys to explore. And then you will also see that there's a difference. Kasi yung AIC, backward regression using AIC, the AIC will still include a variable, even if it's not significant, for as long as the AIC goes down. So there are instances when even if that variable is no longer significant, we still include it in the model. Okay. All right. So let's go back here, class. For your assignment, I want you to look at this, at all of this, no? At most of this, the guides. So take a look at your variable selection, collinearity diagnostics. Okay. So for example, okay, let's take a look at this first. All possible regression. So this model, OLS step all possible. So let's copy this. Control C. And then let's run this. What will this do? So we just change this. This will be mod That's our object. Okay, and if we run this, okay, look, there are 110, okay, 127 rows. Why is that? Let's give this a name. Let's call it all models. Okay, let's once again run this. And then ito na yun, di ba? All mod. Let's view this. All right. So you take a look at this class. What do you have here? We have here all possible models. So we have okay. Hindi nakikita, no? Okay, here we have just education, just tenure, just gender. So we have the first 7 are on simple linear regression using either education and tenure, gender, etc. Now you can see here that this is ranked accordingly. May rank siya. No? Now if you will just do simple linear regression, you use education. Okay? Ano yung mga Ano yung mga it's adjusted R squared here. Among the simple linear regression, this is the best. No? Okay. CP is Mallow's CP. And here, yung Mallow's CP. Okay. It's actually a metric, Mallow's CP. So kindly read a bit on that. And the lower the Mallow's CP, parang AIC din siya. No? The lower the Mallow's CP, the better. So if we were just taking a look at a simple linear regression, ang pinakamaganda in terms of Mallow's CP is use education. In terms of AIC, si education din. In terms of SBC, si education din. And there are other metrics that we can use. Tapos yung next batch is you have 2 predictors. Yan, di ba? From 8 to 12. So this contains all the possible combinations. Kung isang predictor lang, kung dalawa, kung tatlo, and it's ranked accordingly. Kung dalawa lang predictors na gagamitin natin, the best is education and tenure. Yan. Ang adjusted R squared niya is 29.91%. And you compare that with the others, then siya yung pinakamaganda. Okay, ganun din. Sa Mallow's CP, kung dalawa lang, ano to? 2 predictors, this will have the lowest Mallow's CP. 54, tapos 89 na, etc. Akaiki also, 2685, 2716. Okay, so from all indicators class, if you only choose 2 predictors, I think from 8 to 16, then you should choose race and tenure. And then it goes on, class. Now, yung 2 pala, marami, no? Kasi combination yan eh. Okay? Combination yan. Education, tenure, lahat ng education, then gender naman, experience, etc. So, maraming number 2. There, hanggang 28, no? Ganun din si number 3. Okay, so all in all class, there are 127 possible combinations if you have 7 variables. And there's a formula for that, no? There's a formula for that. And I want you to explore ano yung formula if you have 7 variables, okay? If you have 7 variables, ilan yung possible na combination? 7 predictors. What do you think, class?
Hello, sir.
Yes?
7 choose 2. So 28. 7 times 8 over 2.
So paano?
7 choose 2, sir.
7 choose 2.
Yes po. Which is 7 times 8 over 2, so 28 po yun. Pag dalawang factor.
Pag dalawa, then I'm asking for the whole. Lahat.
Sir, it's the summation of NCX, sir. Number of total variables. Tas kung from 0 to n po. Type ko na lang, sir.
So summation ng ng choose ng 7 choose 1, 7 choose 2, 7 choose 3.
Yes, sir. Hanggang 7 to 7.
Pero mahaba 'yon, no? There's a shortcut formula for that. Kung iisa-isahin natin, mahaba. What do you think is a shortcut formula?
Sir, 2 raised to the number of variables minus 1 po.
2 to the?
The number of variables minus 1.
Yeah, oo. So it's 2 to the n class, no? 2 to the n minus 1. Okay, so let's write that, no? 2. Okay. Yan ko. So the formula, let's say you have 10 variables. The formula is 2 raised to the n column natin ng wage minus 1. This is the number of predictors. Okay, n column, yung wage function natin, ilan ba yung mga ano na? 'Di ba? 8 yung ano nun, 'di ba? Okay. 'Di ba 8 siya, no? 8 variables. Bawasan natin ng isa kasi yung pang 8 doon, yung hourly wage, yung dependent variable. Okay? So 2 to the 7 and then you subtract 1. 127 lahat yun. Okay? So that's the number of possible na model if you have 7 predictors. So tingnan niyo, 127 yan. Okay? And yung pinaka 7 class, isa lang yan kasi lahat yan, di ba? And there's a way to choose among this. Ano yung best na ano? If you take a look at our guide class time na, no? Okay, these are all the step, all possible. So it will give us, in our case, it's 127. Okay, pwede din natin i-plot. So may I request you guys to go through this guide. Tapos you try to run kung ano yung best sa atin. If you take a look at this best subset regression. Okay, what does this do? Control C, run natin to, no? Before we call it a day, kasi punta time na. Okay, so let me go here. Yung best subset, oops. Control V. OLS best subset. Mod. Let's call this K. Okay. And run this. Okay. Okay, what will K give us? It will tell us, class, if you are only choosing one variable, okay, then choose education lang. Because among the one variables, ito yung pinaka-best. If you're choosing 2, then choose education 10, etc. Of course, 7, iisa lang naman yan. But if you're going to compare all of this, if you're going to base it on the adjusted R-squared, sino yung pinakamaganda sa kanila? Based on the adjusted R-squared, it's 36.3, no? Ito. Ito, 36.3. Ito yung pinakamaganda. So you have 6 variables. Okay? But based on Mallow's CP, ano yung pinakamaganda? Yung lowest, no? So ito, education, experience, tenure, gender, civil status, 5.83. Based on Mallow's CP. Based on AIC, okay, it is ito, 5 din, no? Okay? However, class, again, may iba pang mga may mga iba pang parameters. But again, class, ang let's say quote-unquote disadvantage of just using Mallow's CP or AIC is that it does not take into consideration yung yung statistical significance ng variable. Kasi if you take a look at, wait, 1, 2, 3, 4, 5, ito 5 no? Si Mallow CP. Okay? Pero if you take a look class at predicted R squared, anong pinakamaganda dito? R squared. So this is similar to adjusted R squared. Medyo related yan. Ito naman yung predicted values. All right. So it's time, class. Now, may I request you to please check. Okay, actually, pwede natin i-plot, no? Tingnan natin last, i-plot lang natin tong K natin. Okay, and let me just show you. Okay, plot. Okay, we can plot this. Okay, then this gives us this, no? Pito. Ito, tingnan natin. Okay. All right. So this tells us that in terms of R squared, syempre, ang pinakamaganda yung 7. Okay. In terms of Mallow CP, so this is 1, 2, 3, 4, and 5. Yan, medyo magkalapit si 4 variables at saka si 5. Okay. Tapos, in terms of adjusted R squared, of course, we expect adjusted R squared medyo dito. 3, 4, 5, medyo dito. And then AIC, the lowest, AIC is either, I think, 4 or 5. All right, so that's what we can see from the plot function. Okay, so sorry for extending. Let me just, may I request your class to please look at the others. No? We will finish this next meeting and then go to other forms. Ito importante sa ating next meeting, class. Residual diagnostics at saka itong tatlong to. Actually, itong 4 na to. Kasi we were looking at variable selection, which variable to choose. So now, having chosen yung 4 based on p-values, we will now look at does this model quote unquote comply, or is it consistent with the assumptions of classical linear model regression? So we will look at residuals, influence, heteroscedasticity, at saka yung collinearity diagnostics. All right. So thank you so much, class. Thank you, and I'll see you next meeting. I hope you learned something today.
Thank you, po, sir.
Thank you. Thank you, class.
Thank you so much, sir.
Thank you.
Thank you.
Salamat. Salamat. Thank you. May magpapacheck ng attendance? Wala. Okay.